In the previous video, we learnt about sample space, correct? Now, in this one, let's solve few problems, example problems on how do we calculate sample space. Alright, look at the first one. See, this is a standard question. A coin is tossed 3 times. What is the sample space? See, for this one, let's take, see, all the possibilities we need to take, correct? So, first what we'll do, we'll take a possibility of, see, let's say this is the first toss, second toss, third toss. Alright. Now, the first toss, let it be head, head, head. Okay. This is head and head. But in the next one, this can be a tail. Correct? Or the next one is going to be, this is going to be head. And this is going to be a tail. Correct? And this is going to be a head. Possibility. Or this can be head. And this can be a tail. This can be a tail. See, this is one possibility. Or the next one. So here, how many we got? We got 4 possibilities, isn't it? Now, can you figure out a pattern here? See this one, the third one, that is the last one. We have alternate head and tail, head and tail, head and tail. The next one, you are going to have 2 heads, 2 tails, 2 heads, 2 tails, isn't it? So for the last one, we have head, 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 head. Now what do? We are going to take a tail. Okay, we have tail. This is going to be a head. And this is also going to be a head. Alternate head and tail, isn't it? The next case, this is going to be a tail, correct? And this is going to be a head. And this is going to be a tail. Alternate. Next, we have tail. This is also going to be a tail. And finally, this is going to be a head. And the last one, tail, tail, and tail. So how many are there? If you look at it, you're going to have, here you're going to have 4. It's starting with head and 4 starting with tail. Correct? So the sample space, when you're writing sample space, we write it as this. S is equal to H, 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 T, or next one, H, T, H, so on and so forth, till T, T, H, T, T, T. So in total, we are going to have 8 possibilities in the sample space. So this is how we write the sample space for the given question. That is, when a coin is tossed 3 times. Now, it's a very standard and very easy problem, actually speaking. Okay. Now, you're going to have compound things like a coin is tossed, a die is rolled, or something like this. Basically, combination. Alright, now let's do the second one and see what type of problem you have and what is the sample space you need to write. Look at this one. A box contains 3 red, 2 white balls. All of them are identical and are drawn at random without replacement. What is the sample space? Okay. What we have is, we have 3 red and 2 white. So in total we have 5. Isn't it? Now we can make use of the combination. Okay, we can make use of combinations, or if you want, we can write it in the axiomatic approach. See the previous one, what we did, that's a classical approach. The axiomatic approach in solving the probability question. Alright, so you can do both the ways. Fine. Here what we'll do, there are 3 red and there are 2 white, correct? In total we have 5. So out of 5, what we are going to do, sample space S is equal to, see there are 3 red, no? So we'll call them as R1, R1, R2, R3. These are 3 red, and say W1 and W2. White, there are 2 of them. Now, when you're picking up these things, you can choose any order, in the sense, even if you choose R2, then R3 and W1, or whatever it is, correct? And that to the same. So you're going to pick up at random one, correct? So out of R1, R2, R3, I can pick R2 or I can pick R1, anything. So the first one is going to be 5C3 out of 5. I'm selecting 3, or since you're selecting 1 here, so we can have 5C1, correct? So directly when you say 5C1, and you're just gonna pick any one of them. But which one are we picking, red or white? That's very important, correct? So what we are going to do, so 5C1, or you can write the next one. Look at the second problem. A coin is tossed. If a tail comes, then a die is rolled. If an odd number comes in the die, then the die is rolled again. What will be the sample space? Okay, now this is a very not complicated, more like there are many things happening here, correct? First, what we'll do, we'll write down what are the possibilities of a coin toss. In coin toss, we have two possibilities, head and a tail, correct? So first what we'll do, so we are going to look at two possibilities, that is a head and a tail. Now, in this one, head and tail, if a tail comes, then a die is rolled, correct? So when a die is rolled, you have 6 possibilities. 1, 2, 3, 4, 5, 6. 4, 5 and 6. Correct? Next, what is the question saying? If an odd number comes in the die, then the die is rolled again. Isn't it? So when the odd number, that's a 1, 3, 5. If 1, 3, 5 comes, then the die is rolled again. Again, you will have 6 possibilities. With 3, again, you are going to have 6 possibilities. With 5, you are going to have 6 possibilities. Correct? What will be the sample space? Okay. So in the sample space, suppose if you get a head, that's all, correct? There is nothing further. But when you have a tail, then we have beautiful combinations. So when you get a tail, so first what we'll do, we'll take the even numbers, because odd numbers will do it again. Because you're rolling the die twice, no? That's why. So if it's a tail, suppose if it's a 2, you keep it as it is. You can have a tail in 4, you can have a tail in 6. Quite simple. Now let's do the interesting part of the problem. That is, when you have a tail and 1, again what are you going to have? You can have 1, 2, 3, 4, 5, 6. Correct? So within the tail you can have so much. Or suppose if it's tail and 3, you can have 1, 2, 3, 4, 5, 6. Or tail and 5, 1, 2, 3, 4, 5, 6. Okay, now if you stop here, that's it. This is going to be the sample space. But if you don't, that is every time you get an odd number, if you keep on, rolling the die, then the sample space will keep on going. This is going to be the sample space. All right. So for the given question, the answer is going to be this. Fine. Guys, these are simple examples as to how you need to write the sample space. Okay, how you need to write the sample space. Now, in the next one, we look into the most important part of the chapter, that is defining an event and types of events. All right, once you have understood that, then we will be able to solve few problems on the concept of event and types of events.